Okay, so talking about redox titration now. So before we understand redox titration, I'm going to talk about just a simple titration. Now, titration is a method used to find out the amount of substance using volumetric analysis. If we're talking about volumetric analysis, we're going to see this setup. I hope it will be good. I'm not an artist. Okay, something like this. So on here, this thing we are having is a burette, which is used to transfer known volumes. A burette is going to be used to really not to transfer, but it's used for titration, to titrate. So what you are able to see here is a tap. You are able to open and close this tap. Now the way the burette reads is on top is going to show a 0, and then there are a lot of them. It can end up to 50 or end up to 25 depending with which one you're using. So when you open the tab, the content will start getting down. So the volume, if it moves from 0, maybe it reaches a 10 here, meaning that the volume that you have used is 10 milliliters. It is in milliliters. This thing you're able to see here is called the conical flask. So if they ask you what is the use of a conical flask, it's used to hold content during a titration. Now what happens is in the burette you are going to fill a substance. This substance you are going to be mixing it with another substance that is in this solution. Now a burette also has got a fixed volume. So some will read 50, others are going to read 25, but most of the ones you are going to be using in a lab are going to read 25. So if you fill it at the end there, it means that the volume of liquid that you've put in here is 25. Okay, so the substance that you are going to add in a conical flask is called the analyte. That's the one you are trying to analyze. So the analyte is a substance whose volume is known. So you say known volume, but you don't know the concentration. You want to find out the concentration and the unknown concentration. But in the burette, the substance that you're going to put in the burette is known as a titer or titrant. The titrant, you know its volume, so it is known volume and known concentration. That's a difference. A substance whose volume and concentration is known is called a standard solution. So in this one you are going to add a standard solution, a substance that is of known volume and known concentration. So what is going to happen is this. Remember, for a chemical reaction, let's say you are using hydrochloric acid and sodium hydroxide. This type of reaction is called the neutralization reaction. So this is going to form sodium chloride and water. But how do you know that the reaction is complete? For example, when the thing that you are adding from this point, from the burette, remember you don't know the concentration of the thing that is found in the what, in the conical flask. So as you are adding the thing from the burette, you want to find out, let's say this one is the titrant. It's the one that you are adding to the analyte. Let's say that's the case. So what is going to be happening is this. as you are adding the titrant to the analyte. Before you even start adding, you are going to put something here called an indicator. You are going to add an indicator. You are going to use a test tube. You just add maybe 2 drops or 3 drops of indicator. You don't add a lot. So when you start adding the titrant to the analyte, the reaction will start happening. You start forming sodium chloride and the water. So some indicators have got a certain color in a certain solution. For example, sodium hydroxide is a base, and then hydrochloric acid is an acid. So you see maybe the indicator that you added is what? Is yellow in a base. So meaning when I add this indicator to the sodium hydroxide, the solution is going to be yellow. But when that same indicator in the acid, it might be maybe pink. So what is going to happen is when I start adding the hydrochloric acid to the sodium hydroxide, the solution will still be yellow, but I'll reach a certain point when the color starts changing into pink. Immediately it starts changing into pink, I'm going to know that, well, all the sodium hydroxide has reacted. And now what I'm still adding on is what? Hydrochloric acid. Why have I known that all the sodium hydroxide has reacted? Because the color has started going to the color for the acid. Now, that point when you have just added enough titer to the analyte, just a point when you have just added enough of hydrochloric acid to the sodium hydroxide such that you have now formed this and this, you have not exceeded the normal one. That point is called the equivalent point. The other word used for equivalent point is stoichiometric point. But how are you going to tell that you have just added enough titrant to the analyte? You are going to tell by the color change. And at that point when the color actually changes, that is called the end point. So you should be able to differentiate these two terms. What's the difference between equivalent point and end point? The end point is a point in a titration when the color or the indicator changes. The equivalent point is a point when you have just added enough hydrochloric, I mean not hydrochloric acid because it can be a different substance. When you've just added enough titrant to the analyte to react with it. So that is it. Okay. Now, some indicators that you are able to use, let me give them and also their colors. I'm going to put indicator here, its color in an acid and its color in a base. So the common one I think which you used in grade 12 is the litmus paper. The litmus paper itself is of purple, it's purple. When you get to add it to an acid, it's going to turn red, and then in a base it turns blue. So whenever you see that the litmus paper has turned red or blue, you should be able to tell in which medium it is. And then the next one we have is methyl orange. This is another indicator. Now methyl orange is just like a liquid and its color is yellow. So in a base, methyl orange is still yellow, it's still its color. But when you get to add it to an acid, it's going to be changing. For example, it is going to move from yellow if it is a weak acid, it is going to go to orange if that acid is a bit strong, and then it's going to go to red. That means that acid is very strong. So not the color changes. This can be asked. And then another common indicator that is used is phenolphthalein. Now for this indicator, what happens is that the color in an acid, it is colorless, it doesn't have any color. But in a base, this indicator can either be pink or red. Other indicator is bromothil, bromothiumo blue. Well, the names here are trick. And this indicator is green. So in an acid, its color is yellow, and in a base, this color is blue. So you should be able to tell when the color starts changing to this one to be able to tell the end point. Now, in an acid to base titration, we have got three types of titration. One is acid base. This is the example that I've given you, hydrochloric acid and sodium hydroxide. The next one, you have got uh, back titration, and then you have got a redox titration. So these three types of titrations. Acid to base, that's also called a direct titration or simple titration. But at times the same acid base can also be a back titration. We're going to understand that later. Now, mostly you're not going to be advised to use sodium hydroxide as a titrant. Here, you'll not be advised to put your sodium hydroxide there. The question is why? Why don't they allow for you to use sodium hydroxide in that thing? So sodium hydroxide, because this portion is open, can easily react with carbon dioxide from the environment, and because of that, that is going to form sodium carbonate. That is a solid. This solid can come and block the tap here, so that even when you open the tap, nothing is going to go down. So that's why I'm not advised to use sodium hydroxide in the burette. Take note of that. Again, hydrochloric acid might not also be advised for you to get to use in the burette. Why? Because when you're adding the hydrochloric acid here and it gets to spill on you, this is so corrosive, it's going to burn your skin like that. And also, when you're working with this, make sure that you clamp this stand at your own height. At this point, if you are this tall, make sure that you clamp it at your own height. You shouldn't clamp it such that you are looking at it in this direction. It becomes so high. Why? Because when you start adding whatever you'll be adding, that if it drops into your eye, it's going to corrode you. It's going to cause you harm. So make sure that it is at your height. And again, when you are smelling things that you are dealing with, for example, sodium hydroxide or hydrochloric acid, don't put your nose on the container that contains these particles. Don't do that. They can destroy your nose. Okay? So how do you then smell things in a lab? What you are going to do is you are going to get that same thing, just bring it near your nose. Don't smell the thing. So let's see if I can show that. So here you are. You are just going to get that. You are going to get a test tube containing that particle just at a distance from you, and then start fanning it. Okay, using your other hand, you are pushing air towards your nose like that using your other hand, and then the hair will be going to your nose. So how do you smell things in a lab? You fan the the smell towards your nose at a distance. Don't bring it near you, otherwise that's deadly, it's dangerous. When you're talking about a redox titration, you don't use an indicator. A redox titration has got a reducing agent and an oxidizing agent. The reason as to why you don't use an indicator is because it is self-indicating. For example, if you have got iron 2 plus and this went to iron 3 plus, iron 2 plus has its own color and iron 3 plus also has got its own color. So if you just see that the color has changed, maybe from this is from green, let's say, to red, just know that iron 3 plus has been formed. So you don't need any indicator for any redox titration. All right.